All right, boys and girls, welcome back. It is Wednesday, and today there is a live class at 11:30. You don't have to watch this video to get an understanding of this, but here you are watching it. You can change your mind and decide to come at 11:30 today, and we'll work out problems together and complete the assignment together. But right now, if you're watching the video, what you should be doing is solving the sample IXL problems with me. Okay, and the title up here says find probability with two-way frequency tables. That just means what are the odds that something is going to happen? What are the chances? What is the probability? Okay, so we can analyze the data and the statistics to figure out what the chances are that something's going to happen. And this is very helpful in our everyday lives. Okay, so this says watch the video and work along. Click the link and work for 25 minutes or until your score is 100. If you can't get to 60 in 15 minutes, contact me or join the Zoom meeting. Oh, that should say at 11:30 for a better understanding and full credit. Okay, so there will be a link in here tomorrow with this video on it. It says add a private comment about your score and time, and then mark as done. And so we're going to click on this link and we're going to go find probability. All right, I'm going to take some snapshots. We're going to solve some problems together, and I'm just going to kind of show you how this all works. So now we've got this two-way frequency table that I'm going to take a snapshot of, and there's a scenario there with it. Okay, and the scenario paints a picture. It tells us what that data is all about. Okay, it says a health instructor surveyed all of his students and tallied the results. The first survey question asked, do you adhere to a vegetarian or an omnivorous diet? So they asked this first question, and that first question is answered. Okay, it's answered over here, these two rows of data. Okay, so you can see 5 people and 1 person have vegetarian diets. And then as we continue reading the question, it says the scenario rather, it says the second question asked, if you were to buy a pet today, which animal would it be? So these are the 2 survey questions from the health instructor, and the 2 column headings up at the top are dog and cat. Okay, and each respondent gave an answer to the vegetarian diet or the omnivorous diet, and each respondent gave an answer to the dog and cat question. Now down bottom is our question. Okay, what we're trying to figure out here, and I'm going to highlight it yellow. It says, what is the probability, what are the chances, what are the odds that a randomly selected student adheres to the vegetarian diet and would buy a cat? And really key here is this word and. Okay, so we're trying to meet these 2 different standards. We're trying to do adheres to vegetarian diet and would buy a cat. Okay, so the vegetarian diet we see is, I'll underline it here. The vegetarian diet is that, well, that's a little bit too thick. That's not really working for me. So the vegetarian diet is this top row right here. Okay, this top row of data. So 5 people who said they chose vegetarian diet chose dogs, and 1 person chose cats. So really what I'm looking for here is this one, the 1 person who chose a cat and a vegetarian diet. Now, it's the probability that a randomly selected student adheres to that set of rules, the vegetarian diet and the cat, out of the total number of people who are being surveyed here. So I have to take 5 plus 1 plus 4 plus 3. Okay, the total number of respondents, that's going to be the denominator of my fraction. Okay, so I have 6, 10, 13, and I know that only 1 out of those 13 wants a cat and a vegetarian diet. So I'm going to go right in here and I'm going to say 1/13, and I'm going to submit that. Okay, and that's all we're doing here, is we're finding the probability of things, the chances of things, or the odds of things. And it does say simplify any fractions. So make sure that you're reducing any of these fractions. Okay, I'm going to take another snapshot. We're going to work another problem out together here. again, we're finding the probability of an event happening based on data in a two-way frequency table. Okay, so we can read these scenarios that explain the situation. It says Roy entered his sisters into their town's smelly shoe competition. That sounds like fun. I wonder who the judges are. Roy observed contestants of all ages proudly strutting about wearing different kinds of smelly shoes. Okay, so we've got a bunch of data here. And basically we've got some column headings that are about ages. Okay, and our age groups are under 12 and 13 to 30. And then we have, I'm going to underline in gold, or I'm going to put in a box in gold over here. We've got two row headings. Okay, these participants are wearing tennis shoes or they're wearing high heels, and they're in two different age groups. Okay, and we're trying to find what is the probability, what are the chances that a randomly selected person is wearing high heels and is under age 12. So wearing high heels and under age 12. It's really important to find all those keywords. So I want under age 12 and wearing high heels. So I have 9 that are under 12 and wearing high heels. Now, how many total people am I talking about? Well, that's 8 plus 9 is 17. 8 plus 9 plus 14 plus 7, because that's the total number. Okay, so I have 14 and 7 is 21, plus 9 is 30, plus 8 is 38. Okay, so I have 9 over 38. And remember, it says that you need to reduce that to lowest terms. So if you can't reduce that in your head, or you don't know if you can reduce it, remember, push 9 ABC 38 on your calculator and push enter, and it will reduce that fraction for you. And if you do that, you'll find that that is the fraction in lowest terms. So let's go see if we've got this right, and if we don't, let's learn from our mistake. All right, let's see here. Terrific. All right, so we're gonna try and jump another level here and see if we get anything different. Okay, this is the exact same thing. So I'm going to try and go over here. Let's see here. I'm going to try and go right here where I have a little bit more of a challenging problem. It kind of adds another element here, okay? Because now I've got 3. Let's see here. I've got 3 row headings. I've got red beards and gray beards and brown beards. And I'm not even going to read this scenario this time, because I know that I can probably read the question and figure this out. Okay. I've also got some column headings up here on the top. Okay. These people are either only in the beard competition or they're also in the mustache competition. Okay, and so there were a bunch of respondents who were surveyed, and they were asked what color their beard was, and whether they were in a beard competition or a beard and a mustache competition. So it says, what is the probability that a randomly selected contestant has a red beard, given that the contestant is also in the mustache competition? Oh, this isn't the problem I want. I got on the wrong page here. I'm sorry, boys and girls. Let's see here. I want what I'm looking for here is something a little different. And I'm sorry that it's taking me a minute here, and I'm sorry I made that little mistake. I'll get something. All right, we're going to try this one real quick. We're going to run right through it. Okay, it's the same kind of thing. We're trying to figure out what is the probability that a randomly selected student wants to be a doctor and has a fear of heights. So doctor and a fear of heights. So doctor and a fear of heights, and that's this right here. So 5 out of the total, okay, and the total is 24. So my probability is 5 out of 24. Now, this will actually also let you do this. Let's see, 5 divided by 24 equals, can't, if it's a terminating decimal, then you can type it in as a decimal as well. But we're just going to do 5 over 24. 5 over 24. So 5 out of 24 are the chances that this is going to be happening. All right. A sociology teacher asked her students to complete a survey. Let's see here. To complete a survey at the beginning of the year, one question was, how responsible are you? The other is, how many siblings do you have? Okay, so the number of siblings is here on the top, and the number of people who responded as responsible and irresponsible are over here, the row headings. Okay, so those values, irresponsible and responsible, go across, and the number of siblings go down. Okay, and we're trying to find what is the probability that a student is irresponsible and has 0 siblings. So we want both irresponsible and 0 siblings, so that's that value right there. So that's 5 out of the total number of people. So that's 5 out of 20, which is reduced to 1 out of 4, right? Which is equal to 0.25. So let's see if that works. Let's see if 0.25 will work in there. 0.25. All right. Okay, let's see where we're at here. Let's see where we're at. We're going to go for another couple minutes. I'm going to try a couple more of these with you guys. Okay. I'm trying to find a different problem, a different kind of problem. And I know you might see one of them because I've already worked through these things. Okay, I'm not even going to read the scenario. I'm just going to read the question. It says, what is the probability that a randomly selected participant spun the second wheel and landed on matches and the first wheel and landed on desert? So they spun 2 wheels to get 2 different things. And when we want to find when they spun one and landed on matches. All right, so we want to find where matches and desert. So we want matches and desert, right? So those are the things we're trying to find. So the number of matches. Matches are a row heading, so that goes across, and desert is a column heading, so that goes down. So there are 11 respondents out of a total of, let's see, 9 and 11 is 20, plus 15 is 35, plus 6 more is 41. So we're 11 out of 41. Let's try it. All right, so the challenge zone. Let's hope we get something different here. I'm going to try and go through this one really quickly and get to another one because I want something different. What is the probability that a randomly selected casserole dish is not filled with cheese? So not filled with cheese. Oh, so that's a little tricky there. Okay, so we're looking for not filled with cheese and not shaped like a circle. Okay, so I have cheese and spinach, so not cheese would be spinach, and not a circle would be a rectangle. So I'm looking at 2 out of a total. How many total famous casseroles are there? Out of 10. Okay, and that can definitely be reduced to 1 out of 5, which is equal to 0.2. And you can put either one of those answers in. I'm going to put in 0.2. All right. And you know what? That's the last problem I'm going to solve with you. What I want you guys to remember is that this keyword here, and, okay, sometimes you may, let's see here, sometimes you may see this word replaced with or. And then you have to look at the data a little differently, okay? So if it does not suffer from knee pain, so that would be somebody who has ankle pain, okay? That would be these two, or is not 13 to 19, okay? That would be both of these, okay? So that would be 13 plus 6 is 19 out of a total of 38. So it would be 19 out of 38. And that would be one half of them do not suffer from knee pain or are not 13 to 19. Okay, so just a little bit different there. Keep that in mind. Read all the words. If you're having trouble with this, if you're struggling and you don't understand, find me in a Zoom meeting. I'm here for you. Thanks.